All right, so now that we've been able to do our first project, we want to go ahead to check other advanced typings in mathematics, and in this video we're going to be considering algebra and calculus. Now for our algebra, we will check binary operations, set theory, Venn diagrams, and matrices, binomial theorems, and every other thing that you can see on the screen. Okay, so now moving on, for algebra, we see that for a typical algebra typings, we have something like this. So for you to type something like this, I'll just show you the codes. All right, so I want to type this. It's basically just you typing and opening a bracket, capital G, comma, and that sign you saw the other time is \O times, then a space. That will give you that sign. That's exactly what this is also. Okay, now there's a way you can write your times in this way. You know, some people just mistake it as X. It's not going to look like the normal times. So you are going to write \times, and it gives you your normal sign for times. Then for this one is \2, and that will give you that sign, such that this is for all X, Y, Z in G. So this for all sign is given by for all, and that changes to that. This is Z in G /in, and changes to that, and that's very simple. Then this is O times, and yes, in, and for all X, blah 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 blah. So then same thing for this one. Now there are two ways to approach this particular one. Depends on the type of O dot you want to get. So if I should do \O dots, you see that there is quite a difference between this O dot and the other O dot, because the dot in this O dot is kind of thicker than this one. So we want the one that is thicker. So I will rather go to symbols and more symbols, and this is it here, right? So you just have to check for it, and you click insert, close. So that's why you can see that they are the same thing here. So it depends on the kind of O dot you want to use in your project. Now this Q, now when you see a letter that is kind of double, the code is \double, it's a capital Q, so space, it gives you that shape. For example, if I want to do something else totally, double, maybe small letter Q, instead is a small letter double Q that's showing. All right, so that's basically what that is required for binary operation. Now for set theory and Venn diagrams, typical set questions will be like this. All right, for blah blah blah. Now you want to know how to write a universal set when you are typing mathematics related to set. So this particular universal set, it's called mu, right? So that's \mu, and that gives you that shape. Now for this one, well, I don't know the name, so I have to just check my inserts. I'll go to now, first of all, you have to check your designs and see if that shape is in your general your default settings. But I can't find it here, so I'll rather go check it from my symbols. Those are the two ways you can get your symbols. It's either you check it the other way and you get what you're looking for. So you look for it, probably you look for it somewhere here, and once you've seen it, yeah, I have seen it already before, so that's it here. They are just, you can insert, close, and that's how it's able to get. So you can use either of these two to represent your universal sets in a mathematical typing. Now same thing, this is a subset. This is a subset. You can also get that done either by going to your designs, then you check the default diagrams, but I think I can't find it here either. So once I can't find it here and I can't really remember the name of the code, I'll just go to insert, then I'll go to symbols, then I'll go check for it. So now by the time you're looking for it, there are some similar stuff. So this is what I was looking for the other time. There's some similar things about it that you can just check. Okay, so it means I'm going to check it where I can find the likes of sets. So I should be around this place. Probably you're looking at like, well, it's not there. You just keep checking, not anything special, till you can find one. So let me quickly look for it. I have to find it too. Okay. So this is it. Then you just press your insert and you'll be able to have the sign just the way you want it. Okay. Then, and to do your set, just do your bracket and put your spaces inside. That's just it for that set. Now for this particular thing, for empty set, you can decide to use \phi. Gives you that sign, or you go to look for this particular shape. So it depends on what you want to look for. If you can use \phi to give you that empty set. Now for this intersection very interesting. I love it so much. Intersection has similar equation that it uses. For intersection, backslash, it looks like a cap, right? So backslash cap gives you intersection, but for your union, it's like a cup, right? Backslash cup then gives you your union. So just like cap and cup. That's for union and intersection. All right. So yeah, so that applies to this one. If I want to write this now, I'll just open my bracket, forget A. Now what's union now? Backslash cup, capital B, then I'll come out of it, correct, and a C as a complement, space. That will give me what exactly I'm having there. So for this kind of thing also, you know how to write your in. Now this one, you can still find it somewhere, I think here. Oh, if it's there or not. Okay, it's not here. You can still find it. Let me see if this works. Not in. Yeah, that's it. Not in, and definitely works. So there's some things you just have to think of and just try it. It works. I'm just trying it too. So I can say not in, then backslash anyways, so it could work. So not in A, then it worked. You just have to write your not in, not a member of it. Basically, that's what you need for sets. Now for matrices, yes, yeah, this has two ways to it. Now you can either go to, after creating environment, this is what I want to talk about. So what you want to create your environment, and once you have your environment, you go to designs, then you which kind of bracket do you need. So just write the type of bracket you need first, then navigate into it. You see matrix here, then you choose the kind of matrix you want to talk about. Maybe it's 3x3, then you can fill up the spaces with whatever you want to fill it with. But I consider this to be too long process for me, so you can write to the code directly. So this is the code for matrix basically. So what you have to do is, first of all, give your bracket, then backslash matrix, then open a bracket. Something will automatically change. So you see that the whole typing has changed to a block, a tick block. So once you open a bracket, then you want to write the number of rows and columns. So at and dollar sign. Sorry, at and an and sign. All right, so close the bracket, then space. So this 2 by 2. I want you to notice something yourself. If I should write at twice and one and I come back here and I close the bracket, you see now, because I'm dealing with the matrix and I want to, the least I can actually work on is 2 by 2. So one at is by default 2 rows, right? Then if I should keep on adding, the more I add at, it becomes, so if I should add one more at, now one at is 2 rows, so adding one at is as 3 rows. If I should add another at, that should be 4 rows. Do you understand now? So let me see, 4 rows. If I should add one and, that should be 4 rows and 3 columns. Do you get? So it's just like removing one from the expected output. So if I should put, for example, if I want to do maybe 5 by 4, so I know that 1 is 2 already. So if I should put 2, 3, 4, then I just have to add one more at. This is 5 by, this is 2 already, 3. So I want to do a 5 by 4 matrix. So I just add one more at to make it 4 columns. So that's it. And you fill up whatever you want to fill up. And probably you've started typing already and you don't want to start again, but you need an extra colon or row. So you can always come to this one of the last row there. You right click, then you can insert row after or row before to do whatever you want to do. So colon before, give you a colon before that, then you can type in whatever you want to type. Grab. So that's how to handle that. You understand? So that's very, very simple to do. And yeah, that's for matrices. Then for binomial theorem, you want to write something like a combination. So this combination actually gave me some tough time when I just started. So what I did was I came to the environment. So I went to scripts. Now this one is like this. I picked the one subscript. Then I made this on my N, and this one my capital C. And now add another sub to that C. That's but underscore R. You see that? So I was able to get out to write my combination for this one. So that same thing goes to the other one. So I'll just come to scripts here, then I'll write N, then a capital C, subscript of whatever I want to write, N minus R. That's it. So for me to write something like this, that's even simpler. Let me cancel out this one. It's even simpler to do something like this. So you just open your bracket. In your bracket, 1 plus x over 2 space to change to that because it's in the mass environment characteristic part 3. Then that's exactly what you're looking for. So for this one, you know what to do, 1 over, then I can write whatever value I want to write it. You see 2 minus x to the power of 3, and that's just it. Then same thing applies to this. Now if you look at this one, it's quite simple to do. So what you just have to do is create your brackets, navigate inside and click and type 10. That's 10 combination 1. Then while you are at that place, you click on enter to take you to the next one. But keep on enter again, so it will be giving me such a arrangement automatically. So it's 1, and that's how I was able to get this ones done. So for this one, it's very simple. Create your brackets and write your what have you inside. So that's for your binomial equation. For logical reasoning, you must have seen something like this before. So very simple to achieve. Just start with your bracket, okay, capital A, then that sign that you want to, your or sign. you go to you see it here, put your design and you see it there generally. So capital B, then your and sign, then open this. Your negation sign should also be there, so you look for it. So I did it here. So you see that I've not been cramming any any code, basically just what you should know basically, and yep, you'll be fine. That's B. So that applies to this. So for this particular formula, this shape, this symbol here, I can just have to go and look for it, but the code is backslash. I think I gave us while I was writing the basic codes, capital L, long right, because it's pointing to the right. So long right arrow, then see changes to that quickly. That's how to do that. And in the case where you have to draw your truth table, just do your normal insert, basic knowledge in your Microsoft Word, draw the table, then insert all of these things, this. Now moving on to system of linear equation. Now this one can really be funny, basically. Now let me just quickly show you what this looks like. If I'm to put it in PDF, let me show you what it looks like in PDF. Let me call this one. So I'll show you what this looks like in PDF format compared to what we are seeing now. The way it appears to be like something like this. I'm coming. Something like this. You see, all those points are not appearing now. This is appearing beautiful now, just like what you want to have. Okay, so this is what it looks like. But checking the way I typed it, look at what it's looking like. Those boxes are there, so don't be distracted by those boxes. So what did I do? I basically used matrix to make it stay together. That's what I used. So look at what I'm talking about. So this is a particular column and a row. 1, 2, 3, 4, 5, we get 6, 7, 8, and 9. This is just like 9 colon. 1, 2, 3, 4, 5, 6. So this is 6 by 9 matrix. So that's what I used to bring them together. So let me just quickly show you how I did it. So don't forget, how do we write it? I don't need brackets for this because it's now system of linear equation. So backslash of a matrix, then open a bracket to make it look like this. And this is true already. Then 3, 4, 5. Then a 6. Alright, then this is 6 by 9. So this is 2. Then 3, 4, 5, 6, 7, 8, and 9. Then close the brackets and a space bar. So I'll have something as much as this. So for the first one, you just type a sub 1 1, then x sub 1, like that, like what you can see, plus you type this one, type that one, then equals to, you fill it one after the other, b sub 1. Right, so you already know what you are trying to create, plus sub 2. So for this one, just write dots, and a dot. You can see then the last one was b sub n. That's how I was able to do that one. So it later formed the system of linear equation that I actually wanted. So I removed this one so that it will not show in my document. So that's how I was able to do it. You just fill everything up and you'll be able to get your system of linear equation. And basically when you see it here, it looks really beautiful. So you don't want to go through that stress of trying to arrange it to be under themselves. That's going to be a lot of stress. You just have to use a matrix and arrange it, and it's going to definitely come out well. Okay, so moving on to same thing you can use to create this one. obtain the rank of. So I used matrix for this one also. There is matrix for this one, so you can get it done with that method too. So going into summations. Now summation, just like what you can see, very easy to do. So just go to your inserts, design, and you see your summation sign here. Pick any style that you want to do, or your product. Pick any style. You can always see a lot of them there. So just do what you have to do. Type them in. Now the major difference between this one looks smaller, this one looks bigger. Now there's one thing about typing in mathematics. Once you type anything on the same line outside the environment, the whole thing becomes smaller. So if I should cancel these bullets outside of it now, so that it becomes bigger. So that's just, for example, look at what I'm saying. I'm done with the environment now. Now probably step outside and write okay. The whole thing becomes small because I've written something else outside the environment in that same line. So what you want to do is to ensure your symbol is at maximum. You always finish writing it, everything you want to write that line on that inside your environment. Do you understand? So that's for that one. Then move to fractions. For your fractions, you just have to utilize the knowledge of your fraction. So how do you do your fraction? Just your slash, enter, space. Then you can fill up this one with whatever thing you want to write and whatever thing you want to write. Then you can have beautiful fractions, just like what you can see. All right. So talking about degrees that's very simple. I just have to have 60, correct 0, then add a space, then it gives you 60%, then 60 degrees. I mean, square roots. Now, how do you write your square roots? You can either write it two ways, just like what I've done here. This one is just square root. This is 6th root. So for your square root, you can either come here and pick the style you want. This is for nth root. This is for normal square root. But instead of going that way, you can still write the code /QRT, then space once and again. So I can bring out this guy. That's you press space twice, then you can fill up whatever you want to do the way you want to write it, and you'll be fine with that. Then for your nth root, you just have to utilize your inserts and something like this. Then you pick nth root, fill up this space with whatever nth root, then this space whatever I want you to do. That will be fine. So for your vectors, you want to have a cap. Now you can always find your cap in your assets. Come to assets, pick the kind of cap you want. With this kind of cap, then fill up the maybe G, then write the way you want to write, and that'll be whatever you want to write there. So that's how to do your cap. Okay, so that's basically simple, and you can actually work out this. Now for your theta, how do you write theta? That is /theta and space. That's theta. Very simple. And moving on to calculus, how do we type calculus? dy by ds, just write dy /ds and dy over ds, then space to give you that one automatically. That'll be very simple. Equals to, now your limits, you just write the limits, then underscore, space. So it will give you the down one and to give you the front. So just fill it up. I give you the data, capital D, that's change in x, then to 0. Then you can fill up the other ones. I will know the name of the symbols and you'll be fine. And if it was to infinity, this 0, so the formula for the code for infinity is /infty. So that's it. It changes to infinity automatically. And yes, that would take care of that one. So integrals, so same thing happened here because I've written something outside the environment. That's actually it's looking smaller, so I'll just have to cancel it. Then it's looking bigger, really bigger. You see, so it's looking bigger now. So just for your integral sign without upper bound or lower bound, so there are two ways you can do that. You can either go to insert, that's the normal routine, design, then come to integral, then pick this integral, pick the one that has boundary. But if what you are basically working on does not have boundary, you can easily write your code \int space another space. That's it. Then you write blah 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 what you want to create, and let's say you want to do double integral \iint. You see that? So the number of integrals you want to do is the number of I you are going to have. Integral 1, 2, 3, NT. That's triple integral. That's triple I. This one works for the one that has no boundary. But if you are looking for the one that has boundary, you just have to go here and do what you have to do. Okay, so partial derivative, same thing applies to. Now the code for there is partial \partial space. That gives you that one with part 2 u over you get what I'm trying to do. So that's it. X with part 2, then you'll be fine with that one. Then you can always type the rest of them the way you want to type them, and that'll be beautiful. Then the final one I'm going to be talking about is a piecewise function. So when you want to type a piecewise function, that is one of the most interesting stuff that you want to work with. For example, I want to create a piecewise function of probably anything. F of x, is equal to. Now, to do your piecewise function, you just have to come to this bracket and you scroll down basically to find what I'm talking about. So here we have it can be 2, can be 3, right? So you just have to do maybe let's pick 2. So f of x is, let's say, minus x, and this is s. So I can put conditions just like the way you usually write it. This is when x is less than 0, right? And this is when x is actually greater equals 0. So I've just created a piecewise function. Very simple. All right, so yes, I will see you in the subsequent video.